Hi everyone, today let's look into the different data processing steps in NLP and why they are used. So basically, if you want to train any NLP model, the first thing that you need to have is you need to have a quality data. So the better the data you have, the better quality the data you have, the better the model will perform. So we need to ensure that we have a good quality of data by removing the noise present in the text and organize it into a proper format so that model can effectively learn and also perform well. Now let's look into lowercasing, which is one of the common data pre-processing step in NLP. Suppose if a text is given to us and the text contains three different words, like these three words shown in the example. So basically we know that all these three words are same, but the computer treats these three words as differently. So basically what happens is when the computer treats these three words as differently, it can affect the performance of the model, as we know that these three words are the same. So by converting them into everything into a lowercase, we make sure that model treats each word as same and model can perform better. And one of the main advantage of this is it can also reduce the vocabulary size, because in this case the model treats these three words as different, so we'll have three words in the vocabulary. But when we converted them into the lowercase, the model treats these three words as same, and what happens is we'll get only a single word in the vocabulary. So basically because of this we can also reduce the vocabulary size. And this lowercasing is particularly helpful in the cases where you need to treat all the words same irrespective of the case variations. So like if you can see that there are three different politics and we need to treat them as same, so in this case lowercasing is very helpful. But in other cases where capital US refers to United States and small US refers to us, and during these kind of things there is a possibility that uh, there is a possibility of lose some meaning. So like even though lower casing is a common data pre-processing step in NLP, so whether we should perform it or not, it depends on the task we are doing, and we should not do them blindly. Removing punctuation is also one of the common data pre-processing step in NLP. So like removing punctuation means like exclamatory mark, question mark, at the rate, removing these kind of special characters. And why do we do these thing is because punctuation marks does not generally add significant meaning to the text. So if my task is performing semantic analysis, and if there are two different text, high, exclamatory mark and high, and for my task, having this exclamatory mark and without having this exclamatory mark doesn't makes much difference. So I will remove these exclamatory marks so I can reduce the noise present in the text, and my model can learn only the useful things in a better way and can perform better. But in certain cases these punctuations might carry meaning, uh, like suppose say I love cake question mark and I love cake. Suppose say if you are developing an NLP model which needs to understand the meaning of the text, but in data pre-processing step if you remove these punctuations, then your model cannot distinguish these two different sentences, which are like I love cake question mark and I love cake are totally two different sentences, and your model will not be able to distinguish these, and it will not work up to the mark. So, and removing stopwords is also one of the common data pre-processing step in NLP. Removing stopwords means removing common words like is, the, and etc. And the main reason why we do this is because the stopwords does not add significant meaning to the text, and so like it basically helps us to filter out the words that don't contribute much to the understanding of the text main topic. Suppose say the example, this is a beautiful day, and by removing the common stoppers this is etc, we get beautiful day, but it still retains the core meaning and reduces the text size. So basically because of this reduce the text size, what happens is our model can only focus on the things that are useful for it, and it can perform better. And there are also some examples in which removing the stopwords can cause a significant loss in the meaning. Suppose say let's take an example, the cat is on the mat. If I remove the stoppers, the is on etc, then we will be left with cat and mat. So basically this will not have any meaning. So basically it lost all the meaning. Suppose if you are developing a model which needs to understand the meaning of the text, by doing such data pre-processing steps, your model will perform worst. And for such kind of task, you should not perform this data processing step of removing the stop words. And even though it's a common data pre-processing step, and whether you should do it or not, it depends upon your task. Lemmatization is also one of the common data pre-processing step in NLP. Lemmatization refers to reducing words to their base or dictionary form. Suppose say if I have three words running, ran, runs, all these three words will be reduced to their base form run. So the main advantage of lemmatization is it preserves the meaning of the text, but still it reduces the vocabulary size. And uh, let's see it with an example. Uh, so there is a sentence given to me, the children are running. After lemmatization, what happens is uh, children will be reduced to their base form child. Running will also be reduced to the base form run. So basically, in this example of lemmatization, it preserves the meaning of the sentence. Stemming is also one of the common data pre-processing step in NLP. And the main difference between stemming and lemmatization is in stemming, you just remove some prefixes and suffixes to get the root form of the word. But in lemmatization, you need to reduce it to the base form which is present in the dictionary only. So basically, stemming simplifies the text and makes it to process quickly. And one of the example can be like running becomes run. So if you take an example, the children are running. So after stemming, what you will get is the children are run. Basically, the running is reduced to run. Basically, you are cutting off the suffix ning. But sometimes stemming can also produce less accurate forms also. Suppose if I consider the word better, so before stemming the word is better, and after stemming the word goes to bet, which are having two completely different meanings. If I do this kind of stemming, if I choose stemming as my data pre-processing step, then my model performance sometimes might not be as good as lemmatization, but stemming is quite faster than lemmatization. So when we need to use lemmatization and stemming is, lemmatization is performed when accuracy and context are very important, because we reduce a word to only its base form in dictionary only. But in case of stemming, we just randomly remove the suffix, so which can also lead to some less accurate forms. So basically, we need to use lemmatization when we need more accuracy and context are important, and stemming when speed and efficiency are matter. And lemmatization requires more resource and time, because we need to uh, reduce a word to its base form in dictionary only. But in case of stemming, we just need to remove some of the prefixes, so it's quite fast. But sometimes it might sacrifice the meaning. The common data pre-processing steps like lowercasing, punctuation removal, stopwords removal, lemmatization, and stemming helps us to reduce the noise in the text and helps our model to perform better. So, but sometimes it can also result in the losing some important information. So, like the which data pre-processing steps we need to perform, that depends on the specific task we are doing, and we need to make sure that no useful information is lost during data pre-processing steps, which results in the which also affects in the model's performance. So we need to make sure that we choose appropriate data pre-processing steps. uh, that's it for now. Thank you.